Hey everybody, this is Larry. This is me going with Cube 4 of the bi-weekly contest 77, Escape the Spreading Fire. Hit the like button, hit the subscribe button, join me on Discord, especially if you like these contest problems and people who like discussing them. Yeah, so this one I find very tricky. I still kind of do, because my buddy Josh, who finished 8th, or I guess a little bit lower technically because of China, but tell me that there is a more straightforward solution. The way that I did it, and I'll go over why, because the reason is that I look at constraints and I said, okay, I didn't want to prove anything, and I wasn't sure that there wasn't an edge case that the greedy would be good for. And the idea is just having two. So I'll go over my solution, and then I'll go over the idea that another solution, I guess, but not in code. But we'll just go over it, and then we'll see if that's good. I probably need more sleep for proving that one, but I just couldn't prove it to myself. But yeah, but the idea is that, well, the first idea is that, let's look at the constraints, right? So we have at most 2 times 10 to the 4 cells. So I was like, okay, that's more. That's like 20,000. So that's binary searchable, right? Meaning that if we have an answer, we can binary search the answer, because if it's 10 to the 9, then and realistically it's going to be way less than that because we don't have that many cells, right? So yeah, so I probably could have optimized a little bit there, but that said, but I also just did, and that's fine. But basically, you do a binary search on the answer. You ask yourself, okay, if I started at X time, can I escape? Right? If you can escape, that means that X is enough time. So then you go try a later time, because that means that everything before that, it's going to be good. So you want to get the latest one, which is good, right? So yeah. So if you want to think about binary search, that means that it's going to be, at 0. If you leave earlier, you're always going to escape, and then at some point it becomes no, you don't escape. And then the binary search is that, okay, if you can escape at this time, that means that your answer is to the right, because you already know that this is the answer, or a possible answer. If this is false, meaning that you cannot escape, then you know that this is not a possible answer, and then that the answer is to the left, right? And that's basically what my binary search here does. And then there's the extra condition of that. If left is equal to 0, that means I just do an extra check to see if 0 is good. If 0 is good, then we return 0. Otherwise, we return -1, meaning that you cannot get to the end. And then the rest of it is just regular. The way that I did it is by first getting the shortest path, using breadth first search, getting the shortest path of the fires. It's a multi-source shortest path, but basically in here, this distance, what does this distance mean, right? That means that because all the fire spreads one space at a time, right? So that means that at unit time 1, all the spaces that can be filled next to it is going to be 1, right? So yeah, that's basically the core idea. And then the distance is going to be, like, for example, if the distance is 5, that means that at time 5 it's going to have a fire, like that space is going to have a fire. That's basically the idea behind the shortest path. And then now the binary search component, I mean, this is just regular shortest path, so hopefully I don't have to go over it too much, because this is a cube 4, so definitely you need to know this as a prerequisite to this one. And if you don't, that's fine. Go back and work on shortest path problems, especially breadth first search ones. And then here, it's my quote unquote, my condition, my good, for the binary search. It means that if we start at time target, can we make it to the end? And basically, this is another breadth first search. Same idea. Basically, if and at every time we check, okay, did we get to this space before the fire does, right? Meaning that if the fire is at the at the exact time that you are, then it is false. And that's basically the idea. Is that I have this condition. I mean, everything is regular breadth first search. Make sure you don't hit the wall, and make sure that you haven't missed it. And here it's basically if you get here before the fire, because this is the fire time, this is your time of getting to the space, then you unqueue it just like you would normally. The only thing that is that, and I think a lot of people got a wrong answer, as you can see, is maybe a little bit less under the top. Oh, shout out to Togas. Congrats. Is that, yeah. However, because if you look at the problem, it tells you that after you move, every fire spreads to our adjacent cell. That means that if you reach to the safe house first, if you reach the safe house first and then the fire gets there, you're still safe. That's basically the idea. And that's why I think that's why a lot of people got a wrong answer. And I had to add this if statement to fix it. And that actually cost me some time. So maybe I could. I mean, well, obviously I would have been much faster. But oh wow, if I didn't get that wrong answer, actually maybe I would have been second. But I did. So I mean, and everyone else did. So a lot of people. But yeah. And that's basically it. So this is the solution that I had. This while loop is a binary search loop. It has O of range of R, or O of log of range. That's called U for range, which goes up to 10 to the 9th. So log of this is going to be equal to about roughly 30, right? In each case, we do a breadth first search. So this is going to be R times C. This is going to be linear R times C times 4 or something like that. But obviously the big O takes care of it. So yeah, and this is of course O of 20,000. So roughly speaking, it's fast enough, but we'll see. So it's a little bit sketch. To be honest, especially in Python. I think in most other languages, not Python, on Leetcode, I wouldn't worry that much about it. But Leetcode's been a little bit weird on running time lately, so hopefully this is fast enough. I mean, it's fast enough to AC, but who knows what happens after the contest. So the one thing that I would say, and this is as an upsell for both you at home and me, is that I couldn't prove this. This is why I didn't do it this way, even though I thought about it. Another way that you can think about it is that you can pre-calculate the time and then figure out the delta, right? Meaning that you have all this stuff. I start at target time and then I do a +1. But you can also just think about like this, and if the conjecture is true, you can think about just having a shortest path from 0, 0 to the bottom right, and then get the maximum or the minimum differences in the shortest path, because then that's how much. Basically, you can think about it as like how much time before you get, like how much time you beat the fire to a certain space, and then the minimum of that path, right? So that would also, according to Josh, who also proved by AC, or I wouldn't say he proved by AC, but as you can see by his AC that it works. But I wasn't able to prove this one because I did think about it during the contest, but I wasn't able to prove it because I thought that there may be some weird thing where like a fire may cut off a path and then you have to go around for a certain time, and that's good enough maybe. But I'm not sure, because I think there is some contradiction proof that because like there is some or maybe like a not quite triangle inequality, but like a grid variation of that triangle inequality, where because you have to go around that path will always be the shortest by a significant amount, and the fire will hit them both first or something like that. I don't know if I believe that per se, but that's what people are telling me. So yeah, I don't know. That's basically the idea. I don't know if that works. Let me know if that works. See if you could have a restricted proof. Leave in the comments. Come to Discord. Come let me know. But yeah, I'll Oh yeah, and this is also all times C, but that's okay. That we only did one iteration of this. So in total, it's going to be and an extra one, I guess. But nonetheless, in total, it's going to be O of log U times all times C time, and space is just obviously linear because of the queues and the distance arrays and stuff like that. So yeah, that's all I have for this one. Let me know what you think. Yeah, you could watch me solve a live in the contest now. What the people already finish? Just fire this grass in the wall. Okay. Surprised no one finished yet, actually. Maybe I can just do -1 bit. Fire is 1. come on, you got this, Larry. Just finish this. Done this a million times. Just finish it. I don't know if this is necessary, to be honest. I might be wrong on this one. Why is it not populating? It's not populating because I don't know how to indent. Is that why? I knew how to indent that time. Oh, I forgot the walls, that's why. That's because I'm dumb. Right. What was my print statement? Oh, huh. Is that the input? Okay, it's not, but if good is... Yikes. People have probably already done. I don't think this... people got wrong answer on this one. Huh. Why is this wrong? What is the visualization here? What's 2 again? Okay, so... You have something like this, you can go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I see. That's really silly. It's because we move and then the thing, so that's a really weird edge case. Okay, fine. Silly mistake. I feel, maybe everyone made the same one though, because it looks like everyone, all the top people got the same mistake. So we'll see if that is true. But yeah, just a lot of typing. We'll see where I end up. 5-minute penalty, so it's going to take 5 minutes. Could have done that one faster. I knew I think that's the thing about not getting enough sleep, to be honest, is that like I knew how to do it quickly, but I just needed to type it correctly. I've been doing this a lot though, where I forgot the words. I feel like I was either practicing or something like that, like recently, where I also forgot the words for some reason. That part isn't that hard to debug, but it's just a lot of typing. I wonder if I could have typed this in a little bit better way. I also wonder if this was necessary though. I mean, it's fast enough, but I think you have to do this every time, but I couldn't prove it because there may be fire that cuts off a path depending on how long you take, versus like you can, because then now you have to take a longer route, so then that changes your shortest path. So that was what I was thinking. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, especially if you like these contest problems. There's a lot of Discord here. Yeah, I'll see you later. Stay good, stay healthy, to good mental health. Bye bye.